Hello, my name is Per Nielsen. I'm from RTX. I will introduce you to the RTX2254 Bluetooth Low Energy RF Tester. Here you see the 2254 connected to a computer. In this case it's a laptop, and it's connected through the USB interface. The 2254 is more or less like a black box where you have all of the measurement hardware embedded into the same box. You have the RF connection to the device under test. You can choose either you would use a USB 2-wire or 4-wire interface to a device, and you can also choose an option where you have support for 2 DUTs in the 2254. The communication to the laptop in this case is through the USB. We use a USB communication to both the device under test and to the actual 2254. What you see here is the main page in the RTX 2254 graphical user interface, and I'll now show how to set it up. You go to the setting page where you set up the COM ports, the virtual COM ports being used for the tester, the generator and the analyzer, and then you simply just open them and the indicator turns green. I'll now show you how to test on a Bluetooth device in direct test mode. I have a demo device. It's a TI device embedded as a dongle. I will be doing a conductor measurement due to its demo purpose. I don't have a shield box right here. Then I'll just connect it through the USB connector here. And connect the RF connection to the DUT0 RF port. What you see here is the interface to the DUT when you test in direct test mode. You can, in this case, I'll be using a USB to a device, and I set up here the baud rate. And I can also choose between the hardware flow control or no hardware flow control, which is similar to 2-wire or 4-wire serial communication. And I have chosen the COM port 6. The related COM port can be found in the device manager. This one, you can just go down here and see the COM ports. In this case, you can see that the analyzer, the generator and tester, they are connected. When you have the device connected, you simply just open the interface and then it's ready. The actual test, I go to the main page, and then first of all I have the measure mode where we will have a direct test mode burst. You can choose the number of packets being used for the iris test, the payload length, the payload type, the generator power, that is the signal generator's RF power to the device for measuring the RF sensitivity. Then over here we choose what port to use. I know I have my device connected to port 0, so I change to port 0. Select. Then press save. Then shortly after, now we can see the device has been recognized. We have the Bluetooth address for the device. Then as default, we perform test on 3 channels. It's in this case I have chosen channel 0, channel 12 and channel 39 to get sensitivity and RF performance on the low, mid and high channel. Then in this window you see the test that can be performed. We can do the frequency offset test, do the TX power output, and then the packet array rate, in this case performed on a predefined threshold level. After you have done the setting, I'll go down to the bottom section, which is called test run. What you see here is just the test status, the cable loss, the number of tests that it has done so far, and then the errors. Then I'll press start and you'll see it start executing the test. Done the first channel, done the second channel, done the third channel, and when they turn green, it's because they have passed the limits we have set up earlier under the configuration page. I will show one more feature, and that is the RX sensitivity test. The test we did just perform was with a predefined threshold level for the RX sensitivity, but I also have a function in the 2254 where it can measure the actual sensitivity level for the device. This is a feature more commonly used for QA departments, for validating manufacturing devices, or for prototype series. I'll just turn on this one. I will then define the generator level, say minus 70 dBm, and then I will start the test, and you'll see it will start on the first channel. You will see that the RX level is now being stepped down until it reaches an error rate as we have defined in our limits on the configuration page. In this case, I know it's 30.8%. You see it measured the first channel to have a sensitivity of minus 88 dBm. The next channel should be close to. Again, this is a neat feature for development, for prototype series, for QA test of devices. From a time perspective, it's not relevant for the production inline test. Yes, and it all passed. I'll now show you another feature in the 2254. Previously, I just showed you test in direct test mode, which is defined by Bluetooth SIG, but due to there's no over-the-air test interface for BLE devices, RTX has implemented support for testing in advertising mode. And I'll now show you how to test in advertising mode. I'll be using a coupling antenna, and I'll be testing on a Apple Watch. With the watch, you just enable Bluetooth in this, so it will start advertising when it's not connected to any devices. Then put it on top of the coupling antenna and then start performing the RF test. I'll now show you how to use the advertising option we have for 2254. First of all, you go to the configuration page, then you choose advertising as the test operation mode. Remember to save. Then you here can set again the test result limits for the frequency offset, for the output power, for the packet array rate, and also for the intervals. How will your timing window be? What will your pass and fail window be? Then you go to the advertising mode here. You set up the cable loss. I know this is a radiated test, and I know that the coupling loss is approximately 10 dB. Another parameter you will have to set is the advertising packet scan interval, which in this case is 40 milliseconds. And this is the maximum waiting time or the interval between the advertising packages being broadcasted by the device under test. I know the device I'm testing here is designed with a 20 millisecond interval, and I have to allow the variance of 10 milliseconds as defined by Bluetooth SIG. So it should go no further than to 30 milliseconds. After configuration, I go to the main page. Then, very similar to direct test mode, we use the advertising burst, the number of packets for the RTX test. In this case, I have chosen 5, which is less than what you typically use in direct test mode. But that is again because advertising mode is relatively slow for RTX measurements compared to direct test mode. But with 5 packages, we have a sufficient accuracy and sufficient indication of the RTX performance. Then you can choose between payload types. Now it shows no scan response, which is mainly for beacon types, where you have no response from the device when you send a scan command. In this case, I will choose scan response. That actually enables us to perform the RTX test on the device under test. Then generate the power level. In the case, I have set it to -50, and I have selected the DUT0, the port. When it comes to the channels, we have 3 channels, and they are predefined by Bluetooth to be channel 37, 38, 39, which is the physical channel 0, 12 and 39. So you have represented the frequency band quite good by using these 3 channels. Here you can see that we have found the device. It has a timing interval of 22 milliseconds. I have chosen the frequency offset measurement, the DUT output power, and then the packet error rate. I'll come back to the RTX sensitivity later in this presentation. Then I just push the start button, and then it will start performing the test. And from a time perspective, it's quite efficient, but that is very highly related to the timing interval for the device. It passed the test. Then I will show you the sensitivity test, and then I just go to a reasonable reference point. It will start off at -70, and then just like for direct test mode, it will start measuring the actual sensitivity level for a device under test. This is again a test mainly for QA assurance, for prototype series and so on, because from a timing perspective it would not be sufficient for an inline test. And the commonly used RTX test for inline test will be with a known threshold level like -85 or -88, depending on the actual device. Another feature in the 2254 is the ability to lock the measurements. Go to the page measurement lock, enable the measurements, and then you will actually just start the test now and show that it will be logging the data into a text file. A text file you can view from the 2254 application, or you can actually open it as a text file directly and import it into Excel or whatever tool you use for analyzing data. Here you see, I can see when the test was performed, I can see the Bluetooth address, I can see the results from all the test performs for all the channels, and then I can see that the item passed all test cases. And you can actually go to, if you look at this, is the folder where you will find the log file. It's under program data, RTX2254 and log. I'll just try and open one of them for you. You can see here it is. And again, the results, as I showed you in the application, is also logged in this text file, and then you can use it in other tools for analyzing the performance of your device. Quite typically, you'll use the 2254 in an ATE setup, automatic test equipment setup, and integrate it into your own application. As earlier mentioned, our physical interface to the box is through USB 2.0, but you will also need an API. I'll just show you here. If you go to the RTX folder in your Windows menu, you will find the API specification, and then open it, and you will find description and explanation about all of the commands in the 2254. Another feature in the 2254 is that we actually provide sample code. You can see in this folder, it will be on under your program folders, and you will have a test project folder where you will find test project made in Microsoft Visual Studio. You can use that in, of course, Visual Studio or in any other C compiler, and that will make you easy started in integrating your 2254 into your application.